Hello, fellow educators. I hope you enjoy reading the Seabird mystery as much as I did. You will find all the resources that you need to deliver this lesson in your Science Scope magazine. This is the story of two young girls who make a grisly discovery on a Pacific Northwest beach. The students are challenged to help the two sisters unravel how dozens of seabirds met their untimely end on that beach. I recommend that teachers use this lesson as a formative assessment in order to gauge how well their students understand the relationship between factors in the environment and a marine ecosystem. The Seabird mystery story makes several connections to the next generation science standards. First, students interpret data that provide evidence of changing ocean conditions and the downward trend of the Cassin's auklet population. Second, students develop a model food chain for the Cassin's auklet, reflecting the cycling of matter and flow of energy in the system. Third, students observe, ask questions, and make inferences using evidence from the story and from provided data. Students determine the cause and effect relationship between changing atmospheric and ocean conditions and resulting changes in the auklet population. The tale of the Seabird mystery presents a phenomenon that is fascinating to students. It begins with two sisters who set out on what would be an exciting camping adventure at the ocean, only to discover dozens of dead birds on the beach. They're confronted with two questions. How did these palm-sized seabirds die? And why are so many birds washing up on the shore? To tackle the question, students have to determine the identity of the mystery seabird first. Then they have to investigate the interaction of three systems: the atmospheric factors like the jet stream, and atmospheric patterns of global wind. How what's happening in the atmosphere affects ocean variables like ocean currents. Understanding of how these factors affect upwelling. Understanding the effects of anomalous ocean temperatures in the Pacific Ocean. Finally, understanding how all these environmental factors affect the Cassin's auklet food web. Teachers can guide students to find solutions by encouraging them to work together to develop a food chain for the mystery seabird. Be sure to review the skills of interpreting graphs with your students. Finally, discuss what the hop blob is and encourage your students to research whether the hop blob still exists in the Pacific Ocean. A great discussion would be whether this is an isolated event or whether this is happening in other parts of the globe now and potentially into the future. With this lesson, you can solve a mystery in a marine ecosystem and bring your students one step closer to systems thinking about real phenomena. The following sums up the concepts of the Seabird mystery. At the end of the lesson, the teacher guides the students to join the links together in this tragic chain of events. 1. The hot blob generates an area of high air pressure above it that disrupts normal weather patterns in the region and prevents normal air turbulence off the western coast of the United States. 2. The hot blob warps the jet stream and interferes with the cold California current. This disrupts the global winds that normally blow warm surface water offshore and aside that permits circulation of deeper, denser, colder ocean water to the surface. 3. Without upwelling of nutrient-rich water from the ocean depths, the surface water lacks the phosphates and nitrates that would normally fertilize the growth of phytoplankton. 4. Lack of phytoplankton means that copepods experience a vast reduction of food sources, and they will not flourish either. Forage fish will starve. Ultimately, the Cassin's auklets will starve because they must compete for a diminished supply of forage fish and copepods.